In this short video, let's see how we can actually work with the index that Pandas data frame gives us. As we've already seen, every Pandas data frame has an index that is by default. You can think of it as a row name or a row number, which goes from 0 all the way through n in increasing order. But Pandas also allows you to do this. You can take any column that you like and make it the name of the row, make it the index. Okay, so you can take a column and you can promote it and say this is my index. So it becomes the row index. It is a way to refer to each row. Okay, why is this useful? Let's take a minute to understand what is going on. First of all, setting index in Pandas is really easy. Okay, so the command is simply very intuitive: df.setIndex and name of the column. Okay, one thing to keep in mind is that you want to do df.setIndex name of the column in place is equal to true, so that you can permanently replace, and now that old 0 1 2 3 is no longer there and there is only this column will become the index. This becomes the index column. Okay, this is the only way to refer to different rows now. Okay, after we do this, why would this be useful? Why are we going through all of this? Because very often we would have one column, one or more columns in our data frame that are happen to be timestamps, right? They could be dates, they could be hours. You could have date and hour. So maybe you want to make that column into your index. First, there's a shortcut called pd.toDateTime. And what this does, as the name says, it converts it to date time. There is a special format in Pandas, in Python, called DateTime. And we are going to take our time column, which usually is a string, right? It's an object, D-type object, and we're going to convert it to a date time format. So if you like, you can even overwrite. So we can say that df of my time column is equal to pd.toDateTime df of this time column. So you see what is going on. What was a string here is now becoming a date time column. And then, of course, we can set this column to be the index. Why are we going through all these difficulties? Well, for one thing, if you have done make that column into your index, you can now sort by time. If you just say df.sortIndex, it will rearrange everything by time. Maybe you had data coming in from different places and you can nicely sort it in ascending order of time. But that is only one use for it. You can do many powerful things. For example, you can say df of 2019 within quotes, and that will select all the rows that are in the year 2019. You can go down to a month. 2019-05 will give you month of May. All the rows that only refer to May 2019. You can even go down to a single date, right? Look at how easy subsetting is now. 2019-05-06 will give you the 6th May of 2019. Finally, you can even do slicing. Because these two are labels, both the ends are included. You can go from 2019 May through 2019 June and July. So 3 months of data in just this one command. Okay. So now let's go over to Jupyter and see this in action. Let's see how setting indices works in Jupyter. Okay. Let me run this and then I'll explain what is going on. All I'm doing is I'm importing Pandas. I have this particular URL which I know I have picked because it has time series data, and I'm reading it. Read CSV from the URL directly. And so now if you print it, you will see that I have date also. This is what I want to use, and then there are many other columns as well. Okay, so I could do something like this. Let's say that my time column is called date in this case. Okay, then I can say pd dot, there is this convenient function that we want to use called pd.toDateTime. Take my data frames time column and try to convert it into time series format. Before that, why don't we do this? Let's do df.dtypes. I'll show you that my date is now what is called an object. So it's just a string. Okay, let it be there. Now let's see if we can take my my df time column and convert it to date time. Okay, it works. So now I can even overwrite my original time column with these new values. So I'm saying, hey, convert all my time column into date time and then overwrite the column itself. And so I've done that. Now if I do df.dtypes, you see it has become a date time column. That was the main purpose of converting it. If you print date now, see it's changed format. Notice that all of these are in the same level. Okay, they're all different columns. But I want to do something. I want to set index this particular column, right? My time column is what I want to make as the index. You can see that it has come down here and all the dates are bolded. It's no longer a column. It's actually become a special index for this data frame. Once we like that, let's go ahead and make int place equal to true. So now if you print your data frame, it's all nicely done. Okay, so we can do something else. We can now do sort index in place equal to. So I actually sorted it. If I print now, it starts from 2015 and goes all the way through 2019. I have 4 or 5 years worth of data. Why did I go through all this trouble? Because now it allows you to do things like this. You can just select a particular year and you can get that year, or if you want a particular month, all the April values are here. If you want a particular date, you could do that too. You can even say go from this date to another date. Let's say we go to May 1st. Okay, and there are a few columns. So there's very nice ways of subsetting. So again, to recap, what we did is that we looked at a data frame, we found a time series column, a timestamp column, it was a string, we converted it to this date time format, we made that the index, set index, sorted it, and now we're able to slice it. Okay, thank you for watching. Thank you for your time.